Hello student, the question says a circular platform is mounted on a frictionless vertical axle. Its radius r equals to 2 meters and its moment of inertia about the axle is 200 kg meter square. It is initially at rest. A 50 kg man stands on the edge of the platform and begins to walk along the edge at a speed of 1 meter per second relative to the ground. The time taken by the man to complete one revolution is. So basically, if I try to draw this situation, so we have a 50 kg man. Initially, he was just standing on this, like he is at rest initially. So after some time, what this 50 kg man did is he started to move on this platform with a speed of 1 meter per second. So as the person starts to move in this, we know by conservation of angular momentum, if the person starts to move forward in this direction, the axle would rotate in opposite direction. Sorry, axle would be here. This wheel, the circular platform on which it is fixed, so it will start to move in opposite direction. So let us assume this is omega 1 of the person. This one would move with omega 2. We know here only internal forces are involved. Forces are involved. And also the net torque acting, because on the person, if it is forward, on the wheel it would be backward. So we can say here net torque is equals to 0. So we can say angular momentum is conserved. Since angular momentum is conserved, we can say initial angular momentum equals to final angular momentum. Initial, I will write L, angular momentum equals to final angular momentum. I'm representing with L. What was the initial angular momentum? Both the person and this wheel is at rest. So both are 0 plus 0. Finally, if I do it, if one fellow is going clockwise, another one would go in counterclockwise direction. So final angular momentum is angular momentum of the person. If I assume person as a point mass, so it is m into v into r is the radius of it. The radius of the wheel is given as 2 meter. So mv into r and plus I will write angular momentum of the wheel on which he is standing, or circular wheel or platform on which he is standing. Rather than wheel, it would be better to write it as a platform. Now, from this we can clearly see L of platform is equals to minus mvr. That means both would be in opposite direction. So once we confirmed both would be in opposite direction, let us just take magnitude. So magnitude of platform is equals to mvr. So I'm only taking the magnitude value. So I into omega 2 equals to m into v into r. So omega 2 would be equals to mass of the body is given as 50 kg. The speed with which he is moving is 1 and radius of curvature is 2 divided by moment of inertia is given as 200. So it would be 1 by 2. So which is nothing but 0.5 radian per second. So this is rotating with 0.5 radian per second in opposite direction. The person is walking forward, the wheel is rotating backward with 0.5 radian per second. We know what is omega 1. Omega 1 is V by R. So V value is 1, R value is 2. So this is also 0.5 radian per second. Now I'll redraw this entire diagram to explain you what is happening. Suppose if the person walks forward in this way, this platform is moving in backward direction. The question is the time taken to complete one revolution. So we just need to find complete one revolution. Like imagine this is the starting point of the person. We have to find how much time it takes for him to again reach this starting point. So to travel in a circle and again reach the starting point. But here the platform is also moving. When two bodies are moving, this is like two bodies are coming towards each other with different speeds v1 and v2, and d is the distance between them. And if somebody asks us what is the time taken for this, what do? We use the concept of relative velocity. We mathematically stop one of the body, we transfer the velocity of this body to other body. So once we mathematically stop this becomes v1, the velocity of this would reach this v2 and distance d. So we will write time equals to distance by v1 plus v2. We use the same logic here to solve the problem, but this is angular velocity. So it's like two bodies traveling with angular velocity. To explain you better, how drawn it as a straight line, omega 1 and omega 2. So and they need to cover one circle, that means they have to cover 2 pi radians. So what is omega relative here? The omega relative would become omega 1 plus omega 2, since both are in opposite direction. One is going one way, the other one is going in the other way. So basically this is nothing but this circular platform. So this is circular platform on which he is standing. So from this we can find time equals to 2 pi by omega relative. So 2 pi by 0.5 plus 0.5, which would be 2 pi seconds, which would be my option 3. I hope you understood how I have solved this problem. Again, I will quickly. So initially a person is standing on a platform. Once he started to move with 1 meter per second, due to conservation of angular momentum, the platform would move in opposite direction. First, we found what angular velocity the platform is moving in opposite direction. It's a coincidence that both angular velocities are same. It is not necessary that every time both the angular velocities are same. So once we got both of them got the same angular velocity, we used the concept of relative velocity concept, similar concept to relative velocity, to find omega relative, and the time equals to the total angle they have to cover is 2 pi divided by omega relative, and we got the answer as option 3. Hope you understood how I have solved. Thank you.